Hello, Mr. Kerr's geometry class. I'm taking a look at your isosceles triangle, CK through 12, and I had to go through it and answer some of these. Hopefully your answers or questions are going to be similar to my questions. Your answers may be different if they use different numbers, but at least you could see how to do these problems. Hopefully they match up perfectly. I don't know, but here we go. My first one was a closed plane figure bounded by 3 line segments is called. Basically what they're trying to figure out there is just another word for a triangle. So triangle would be your answer for that one. That's all they're getting at there. Okay, this one, find the measure of y. What you want to do is you want to take since these two angles are congruent, that means these two sides are congruent. So we'll have 5y minus 2 equals 13. So 5y minus 2 equals 13. There I have the problem, and I have it written out for you step by step, where I added 2 to each side and then divided by 5 each side, and I get y equals 3. Find the measure of x. And you could pause this as needed, but this side is going to equal this side. That's what those hash marks mean, that they are the same measurement. So I set these equal to each other. And when you set these equal to each other, as you're showing your work, you just combine like terms, isolate the variable. This is 11, not 17, 11. And then you get 11 divided by 11, x equals 1. Next one that I had, in an isosceles triangle ABC, A is 2x plus 15, B is x, and C is 3x minus 15. All you really need to know here is at the very end, angle A and angle C are equal. So A and C are equal. So you set those equal to each other. And I even drew it out because with a lot of these, it's nice to draw these out to kind of see what they're talking about. Set it equal to each other and you solve for x. X is 30. Now, I think they give you like one of your answers is 30, but remember you have to plug x value back into the problem because they want to know like what angle A is. So you just plug that in, that 30 back in for the x, and 2 times 30, that's a 30 there, plus 15 gives you 75. So you should have 75 for your answer there. For this one, find the measures of x and y. The way I found y, I did y first. I did 8y minus 16 equals 72 because these two are the same. And there's my work for that one in figuring out what y was. Then I knew that both of those were the same, so they're both 72. So 180 minus 72 left me with 36. And that A is 9x equals to 36. That's what was left. That's how much it would equal. So I just divide to figure out what x is, divide both sides by 9, and you get x equals 4. Find the measure of y. So what if you know that these two are the sides that are equal in isosceles, that means these two angles are equal. So I knew that this was 65. So I took 180 minus 65 to figure out what this angle was. And here I figured out that it was 50. So then your 3y plus 2 equals 50. I subtract 2 from both sides, and then I divide by 3. I get y equals 16. Oh, which is the following is not possible, an obtuse equilateral triangle. Now, equilateral triangles, if I could draw one right here, all the same sides, side, are going to be the same. That means all of these angles are going to be the same. So 180 divided by 3 equals 60. So equilateral triangles will always have 60-degree angles. You cannot be obtuse, so that is what is not possible. If each base angle of an isosceles triangle is given y plus 15 and the vertex is this, then find the measure of each base angle. So this twice plus this once is going to be equal to 180, because all the angles of the interior of a triangle equal 180, right? So the y plus 15 plus y plus 15, so y plus 15 twice, plus that the vertex angle, 3y minus 25 equals 180. I just combine like terms, isolate the variable, I get y equals 35. Now that was one of your answers, 35, so be careful, don't click 35. You got to put this back in because it wants to know what one of the base, what each of the base angles would be. So it would be this 35 plus the 15. Got to go back up here and plug it back into one of the base angles, right? And you get 50. Okay, ABC and DBC are two isosceles triangles on the same triangle, base BC, then which one is true? This one was a horrible question. Horrible question because, you know, there's a couple different ways you could depict it. I at first depicted it this way. And then I was like, no, that can't be, because, you know, it wouldn't be the base. So it has to be one inside the other. And if I could, I started to draw it, and then I was like, oh, wait, I see what they mean. They mean it's like this. So actually, you know, let me make it a little bit neater. B, C, and then you have A here, and then you have D here, okay? So this one, these two, okay? So isosceles, right? So that means that this angle and this angle right here, DCA, DBA, they must be congruent to one another. So my first answer was a mistake. And so it's these two angles, ABD and ACD, would be congruent. And lastly, it's an isosceles triangle. AB equals AC, and a measure of A is 50 degrees. Find the measure of BC. So if this is A, then I just take 180 minus that, and I know that both of these would equal 130, right? So that's two of them. I just take 130 divided by 2. That gives me 65. So each of these is going to be 65 degrees. I hope this was enough help for you. If you need more help, please let me know.